Tekla structural designer software versus Etabs. So I want us to compare Tekla structural designer with Etabs in terms of concrete design and in terms of accuracy of results. Um, we also do other comparisons, but I want us to focus on this because I have done this particular project. I have modeled this affordable. This is a project by Ministry of Land, Public Work, Housing. This is by the government of Kenya. It's called Affordable Housing Project. I was involved in this project. I was a supervisor for a month also, and I was involved in construction, in doing foundation, excavation, laying out of everything, supervising and everything. And also I had access to these details. So this is I have all architectural and also structural plans for this, the plans that we used in construction. And remember, this is a project by the government of Kenya. So let me go to page 45. Okay. I want to go to page 45. So I modeled this building in Tekla Structural Designer and also in Etabs, and I did design. And I want us to compare the two software between CSI Etabs and Tekla Structural Designer to find which software is more accurate in terms of um, slab design, in terms of deflection, in terms of modeling, which software will enable you to be more accurate and more also be able to adhere to standards. And also we compare with what we actually did in what was actually approved in terms of, you can see we have columns here and exactly as we did on site. These are the details we used during this construction of affordable housing. So let me go to Etabs. I will unlock this model. So here are my settings for, let's say, because you can be able to see the design for columns. If I go to frame, columns, modify and show properties, we used 400 by 200 columns. We used 400 by 200 columns. Of course, design is the same, is a residential apartment. The live load is 1.5 or around 2. Dead load for finishes is 1. Self weight is for all frame and also slabs. So the design, we can model the same, but we can be able to see the difference between the two software in terms of the results, in terms of what we get and what is accurate. So this is, we used, for example, for foundation and first floor, we used 60-20. For all columns, the column size are 400 by 200. So this is what I did. And then we used class 25 of concrete because I was involved in construction and I was involved in all those. So we used class 25 of concrete. So here for rebars, for example, let me assume I'm trying to be economical. I will use 216. That is the longitudinal bar, and the corner bar I will use T220, and this one I will use T8 at 200. Let's see if this is accurate, because that is what we did here. We used T8 at 200 links. Let's do that, and then I'm trying to be economical, so I will use T60 intermediate bar and T20 corner bar, but it's also 6 longitudinal bar, as you can see in this detail. If I go to display, assign, you can see assign wall loads, apply. Of course, for the roof, I have applied a wall load of about 3. That is just the parapet. But for rooms, I've because we used machine cut rocks with maybe unit weight of about 20 kN per meter multiplied by the thickness 200, that is 0.2 millimeters, 0.2 meters, multiplied by the height, the floor to floor height, the height of the wall, that is about 2.4, because you normally the floor to floor height is 2.85, and the beam we use is 450. So for 0.45 minus 2.85, you get 2.4. So 2.4 multiplied by 0.2 multiplied by 20, you get about 9.6. So this is the load I've used for our masonry wall. Because we use machine cut rocks, this is not a load bearing wall, so we cannot assume that it's going to the steel frame. But from the foundation to the foundation level, we used the load bearing walls from Bahati Barrow, that is rocks blocks. But for the rest of the floors, from story one, from the plinth level to the other top part, we used machine cut rocks. So I've done the same here. If I go to this display, load assign shell, extra dead load of one for, you can see one for our finishes and partitions, and live load of around 2. The same thing, let's see in our Tekla structural designer. If I go to loads, let me go to loads, and then let's see. I've done pretty much everything the same, the modeling and everything, apart from in Tekla structure. I think because we're using Eurocode, instead of BS 8110, these columns of 200 by 400 were not passing, because I think according to Eurocode the minimum should be around 225, not 200. So 200 will not pass if you're using Eurocode. So if I go to dead, so we're going to do the same. We're going to minimize this. You can see I have a dead load here. For slab, I have about the same for water tank and everything here. So let me go to review and check status. Just uncheck that. And just escape everything. Escape again. I want to see loads, dead load, impulse load. This is my impulse load. You can see I have an impulse load of about 1.5 kilonewton per meter. The same thing, I have a dead load about that is for finishes. You can see there one kilonewton per meter squared, and we have wall load, not imposed. I need wall load. Also, the wall load is 9. If I click on wall load, UDL 9.6 kilonewton per meter in the direction of global Z. So let me go to story one. Let's just work with Eurocode. We use a column minimum size of 225 by 400, because 200 will definitely not pass. So let me change this one. I want to edit concrete columns. Just check everything apart from let's go to base level. I just need to select my columns, select all those, just the columns. All let me show you. I can select up to there, because those columns are similar apart from those two, up to there. Then I will change the dimension to class 25 Instead of that, let me edit. Let me use even 225 because that is Eurocode. Eurocode 200 will not pass. I think so. And performing modeling updates. I hope it's updating for all floors. If I go to 3D, base to top that story, and then select just select those two. Again, I will edit 225. That is the minimum you can use in Eurocode. So we want to compare what we'll find if Tekla structure law design will be more accurate than CSI Etabs. This is CSI Etabs 2016, and we have the results here. This is from the government of Kenya. The results from other engineers. I'm not the one who designed this, but let's check. We're just doing the comparison. Then let me go to 3D. Okay, I'll do the same thing, holding control to select these 4 columns. Also, this one I will change to 225 by 400. Now let's do analysis and design. Static all. The load combination default from Eurocode, or also this we have default load combinations here. So I've no error in terms of modeling, in terms of load combination. Because the load combination, I have this combination. If you can modify and see, is 1.4 for dead plus 1.6 for live. I'm sure we rarely design for earthquake here in Kenya. But of course, wind load we included. But although I've excluded here, let's just check in terms of live and dead load and self weight. Also the same thing here. Let's do analysis. So I've analyzed all static. So we can just go to this result, FZ. I want to see FZ. Okay. I don't want to be reaction. Exit. Okay, so let's just go to design all static. Then I will try to pick the most critical column and let's see the results. We also do the same thing in Etabs and let's see the results. We see which one is more accurate. We're going to also see how if you can design slabs. We check deflection in Etabs, and also we can also check deflection in CSI, in Tekla Structural Designer. So I want us to compare. So here I also do analysis. All my supports are fixed. So the modeling is literally same and everything, apart from this staircase. Maybe I can come, instead of modeling staircase, I can use a line, a member load of about 11 kilonewton per meter, that is for staircase, beam, landing 1 and landing 2. Okay, maybe for landing 2 we can even use 22 kilonewton for holding both first flight and second flight, but for the top we can just use 11 for just that flight. Let's see the difference. Okay, this one I've modeled the staircase and everything. I was not able to model staircase in Tekla Structural Designer. All members are passing, but I have several warnings. However, I have not added landing load, so I will escape. Just I need to select all of this. Mhm. Maybe I'll go to first floor. These are the ones I want. Of course, modeling is the same because, for example, if we go to um, model construction levels, you can see my first, all the other floors are similar to first floor, which is the same as Etabs. Okay, you can model just one floor and then it will be automatically generated for the other floors. So let me add some member load here. I can maybe go load case. Let me add a new load case. Add. I will name it staircase. Okay. Then I'll change this one to staircase. Then I will assign a full UDL of let's say 22 here and 11 here. This will happen in all levels. If I go to this and change here to staircase, you can see all levels have been added, same as Etabs. So I will do analysis, all static. So that is because modeling staircase was not easy here. Maybe I can use those staircase loads instead of just modeling, so that we try to make this result as same as possible. So this the analysis has been done. You can check display. You can display force diagram, support reactions, combination 2, that is the most critical of Z, apply. And definitely the most critical has a load of FZ of 1049. So we can display other force diagram or deformed shape. For combination 2, you can display those. Then we can just go ahead and do concrete design. Remember, for all our columns, we used corners bar, we used T20, and the other bars, that is the intermediate, we used T16. But also it's the same as this project, six rebars, just the same as here. So use 6 rebars. So is that going to pass here in CSI Etabs? Let's check. And what is Tekla Structure Designer going to give us? Is it going to give us the same result or otherwise? Let's see. So let me design all. I want to design concrete, analyze and design all static. Almost through. Now this one has been done. Did all members pass? Let's see. If maybe let me rotate this model. Did all members pass? There are 2 members which are failing. If I'm not wrong, there are 2 members which are failing. You can see I have 2 failed members here. The rest, all of them are passing apart from these 2. If I click this column here, this is the most critical column, is holding the staircase and other slab. So let me click here, right click, summary. You can see at 6 4 T20 corner bar and 2 T16 intermediate, this is over stress. So the OS capacity exceed limit. This is showing that Etabs is very accurate, because from this most engineers go for the most critical design. So if that is failing and he find that 60-20 are passing, he will use that for the rest of the building. So that will ensure this building is safe. So let's change this one and unlock this model and see if I change that one to 2T20, if that is going to pass. That is 2T20 intermediate and 4T20 corner bar. Let me modify, and then this one just change it to T20. Again, we are reinforcement to be checked, not to be designed. Okay. Also for this column, T20, not T18, T20. Reinforcement to be checked. Okay. Now let's reanalyze and then run the design. Let's check the design. All columns are passed. Let me check this column here. This is the most critical column. Right click. We want to check the results for this column. Of course, you can model the roofs separately. So I want to check design status. Right click. Then report for member. Okay, you can see it's saying 6H12. Okay, so let's generate the drawing. Let's go for that drawing. Not report, generate drawing. Okay, it's going to open in AutoCAD so that we can see what it's giving us. Okay, now this one has completed analysis. Now let's do concrete framing design. Sorry, I have a bit of flu, but so let's check. We're going to open this AutoCAD. AutoCAD is opening. Now this one again is doing concrete design check for all members. Of course, you can go reducing the size of rebar as you go to the upper floor, because of course the most critical should be the ones which is scaling the rest of the floors. Okay, one column is still failing, but you can definitely see how accurate this software is, Etabs. If I go and verify all members passed, all members passed the design check. Right, all members passed the design check, but at 6T16, that is 4 corner bars T20 and 2 intermediate bars T20, not T16. This is very accurate and very consistent with what we use in affordable housing project. You can see this is what we used at affordable housing project. However, let's check for Tekla structural design. It's still loading. Let's give it a few minutes. Okay, can we check deflection? To do slab deflection check, you need another software called CSI Safe to do footings and slab design. However, in Tekla Structural Designer, you can just do it right here in this software. If we can go and design slabs. For this slab, I use 150 T10 at a spacing of 'Let's design slabs. All members are passed. We can go and do a slab deflection check. However, did we validate model? Let's see the model. The model need to be validated to be able to analyze. So let's design slab. Okay. And check this. And check that. Slab deflection, analyze and check slab deflection. Yes. So you can be able to do a slab deflection check and in terms of slab analysis, this software is very accurate. The other thing that I realize is very perfect with Tekla Structural Designer is detailing. But here's the catch. Most engineers who are beginners would prefer a software that would do even detailing for them, but you should avoid this, right? You can see the maximum deflection. There's another, I don't know what is this red stuff is. Deflection. So in terms of slab design, it is very accurate. In terms of detailing, Tekla structure is very accurate, but you should be able to even detail when you don't have a software that can detail for you. And I have many videos which show you how to detail manually. So detailing should not be a weakness, because at the end of the day, I think design is the most important part to get accurate results. So detailing, you should be able to do it manually in AutoCAD. So you can see it giving me 4H12. And you can see this is the G plus 1, 2, 3, 4, 5. Structural G plus 5. Definitely, I don't agree. I don't agree with this result. I'm not sure, but you should check even your software, where you download your software. Make sure you download your software from the right sources so that you're not a victim of bugs. But I don't think this is okay. And even if you submitted this drawing, this detailing, this one no one will approve. Although I have H8 at 125, this one I can agree, although it's still our design in terms of shear, but this one H12 longitudinal bar, that is 4 H12 corners and 2 H12 intermediate, definitely I don't agree. There's no H6. It's not good to guess the results, so I don't. So I think in terms of accuracy, I can say the Tekla structure I'm using and the CSI Etabs I'm using, I think Etabs is more accurate and far more accurate compared to Tekla structure in terms of reinforced concrete design. Because I think at the end of the day, the frame is what holds the building together. Without designing the frame structure of the building, that is the beams and the column, then definitely you're not going to get accurate results. Also for these beams, it also gave me the same thing, that is 4H12, which also I don't think so, because that is not what we used on site. And also we have those results here. We can just view the slab beam. I think H10 at 200 is okay for slab, 150 millimeters thick. But for beams, you can see we are using 2T16. That is the most critical. And also you are having some with 3T16. So I don't think just 2T12 all beams is accurate. So I don't agree. But the good thing with Tekla structure is, of course, detailing. You're getting those detailing very accurate in terms of doing detailing, very perfect details. Also, you can do timber design in Tekla structure. You can emulate results. You can do steel design in Tekla structure. The same thing you can do in Etabs. You can do steel design. You can do connection design. You can see this is an option for um, connections. Doing connections, this is still connection. You can do still, but the difference is in Etabs you can only design W section or I section, but in Tekla structure you can design rectangular hollow section, circular hollow section, and any other types, that is it called cold form or all. You can design any type of section in Tekla structural designer, which is not same with um, CSI Etabs. Detailing, I give it to Tekla structural designer. I don't agree with those results in terms of concrete design. I'm not sure. Maybe I don't. You should check where you download your software. I advise you to go to the official website and get those softwares from there. So thanks for watching. I will see you in my next video.